Hi everyone, Science Daddy here, and I wanted to talk to you a little bit more about my Orrey, this beautiful device here that I showed you previously. I wanted to show it to you before I take it apart, and we'll get to that. So an Orrey, it's a mechanical model of the solar system. It's something that shows the motions of the planets around the sun where time is the thing that is to scale, as opposed to the sizes of the planets or their distances from the sun. We're looking at time. Certain limitations, these planets move around in circles. The actual planets move around the sun in ellipses. So at some places in their orbits they move faster, and other places they move slower. But on average, their orbital periods are constant. So what you're seeing here is something called mean motion. So sort of a fictitious, motion of an average planet. So it's good for showing in general where the planets are with respect to one another, but it's not super precise for, if you wanted to do astronomical observations. The name Orrey comes from, one of these was gifted back in 1714 to Charles Boyle, the 4th Earl of Orrey. Where that name comes from, the name Orrey, I don't know, but that name has stuck. Things like this used to be called planetaria or planetariums, but they are, that word has been captured to mean the sort of hemispherical room-sized structure that you would see at a science museum where you can see the relative motions of stars and planets up above. There have been Orreys for hundreds of years, some of them as large as rooms and others that are very small, fitting on clocks, on mantelpieces, and even nowadays you can get really expensive watches that have a fully functioning mechanical model of the solar system. There's other terms for things. There's something called a tellurian, which would show the inclined axis of the Earth and its motion around the sun. So you can see the effects of the seasons. And then there's something called a lunarium, which shows the rotation of the moon around the Earth. And it turns out that this Orrey actually has a special gear set here that lets the Earth-Moon system turn at the correct rate. So it's a combination Orrey, planetarium, and lunarium. So my Orrey has the 4 terrestrial planets, the 4 rocky planets in the inner solar system, and the 4 outer planets, the 2 gas giants, Jupiter and Saturn, and the 2 ice giants, Uranus and Neptune. It also, and I think this is cool, it includes several dwarf planets. It includes Ceres, the only dwarf planet inside the main part of the solar system, in the middle of the asteroid belt there between Mars and Jupiter. It also has Pluto with its moon Charon, and Eris, which is the object in the Kuiper belt, whose discovery was ultimately responsible for the creation of the dwarf planet category. These aren't the only dwarf planets. I think there's at least 10 of them that have been identified now. And the definition is still something that's under debate. So it's like I have been hesitant to put dwarf planets on my arm because I don't know which ones are going to be there in 10 years, how we're going to call them. It's all categorization anyway. So the way this thing works is there's a gearbox and motor down in the base, and it turns a drive shaft which runs up through the middle of the gear stack, and it turns the sun, the prime mover of the system. And as the sun rotates, then through a series of gear reduction ratios, it turns, in turn, Mercury, Venus, Earth, Mars, and so on. And so I'm taking it apart because I think some of the gears, they're not sitting entirely flat. I think some of the washers may need a little sanding. And some of these cantilevered arms here, they pass between some very closely spaced gear sandwiches here. And I want to ensure that even though these move really slowly, some of the cantilevered arms are kind of resting on a gear, and I don't want to risk that it's going to run into it and get jammed or cause any kind of damage to this thing. So I'm going to take it apart, but in doing so, I'll be able to show you the bits and pieces and how it works. So this is going to be fun, and I hope I can put it all back together the way it came. So stay tuned. Okay, so the Orrey has been disassembled, and now you're going to get a look. Here is the motor and central pillar, and right there at the bottom is an engraved plate showing the positions of the planets on the day that this Orrey design was commissioned. Very much like my tattoo or the dedication plaza at the Hoover Dam, it's using the positions of the planets as a clock to uniquely indicate the date and time. So coming back around here, there's the sun and the central drive shaft with a gear and the planet arm for Mercury. So Mercury has a period of 88 days, and coming off of that main gear, there is a planet arm, which is what they're calling it, which has a gear sandwich with a large gear on top and a small gear on the bottom. And then there's another arm with another sandwich here, which has the Venus arm, and it's also a gear sandwich. So if you look at the bottom gear of where Mercury is, this sandwich and the top gear here, you have a 55 tooth gear, 65 and a 19 in this little gear arm here, and then 41 teeth for Venus. And if you multiply those out, you get a ratio of 0.392. And if you divide 88 days of Mercury's orbit by 0.392, you get 224.5, which is very close to the actual number of days in Venus's orbit. It's about an error of 0.16%. Moving on down from the bottom of this sandwich, this gear meshes with this one here on this large engraved plate. It's also got a sandwich that goes down to the next level. And this plate is a nice, it's up near the top of the Orrey, and it gives you 3 different dates that you can ascribe the planets to once it's all reassembled. And then there's another gear sandwich with gear on top, and this is the arm that holds the Earth and the Moon. This particular one, since I mentioned before, it is a lunarium, so there is the teeth around the edge of this gear interacts with the teeth here on the little edge of this arm, which is why this section is a bit complicated, but it allows Earth and Moon to rotate the appropriate number of times per year. Multiplying out those ratios, get 0.16, so 365 days. That's an error of about 0.07% when you compare the number of rotations in the Orrey to the actual number of days that it takes the Earth to go around the Sun. And that's sidereal time, so reference to the background stars. The rest of the Orrey is very much, looks very much like the other pieces. There's a planet arm with a reducing sandwich of gears here, and then the sandwich that concludes the arm for the next planet, in this case, Mars. The upper gear is what turns Mars, well, they're all connected, and then the bottom gear is transmitting the rotation down to the next stack. So you have that ratio and Mars, got an area of about 0.24%, and we're going to move on and see Jupiter, Ceres comes next, followed by Jupiter. And if you notice the errors, this error is a little bit negative, this error is positive, this error is negative, so they're alternating back and forth so that overall the error stays close to 0. So Uranus, Neptune, Pluto, and Eris, all the way down at the bottom, at the very end. And so there you can see the whole shebang all laid out. I'm so happy I have a counter big enough to do this. Yeah, so those are all the bits. And now I'm going to make sure that it's assembled all proper, and I'll get the planets aligned for some date, probably my birthday or the January 2000 epoch, and we'll run it from there. So that's how it works. So what I did was I positioned the planets according to the calibration disk here at the top so that they were in their positions on January 1st, 2000. Then I ran it in the reverse mode for 11 minutes. It moves at about 2 years per minute at its fastest speed. And so I ran it backwards almost exactly 22 years from the millennial switch to my birthday. And that's the position the planets are in now. And it's not quite the same as what I have inscribed on my skin in my tattoo. But I think it's actually due to the errors that are built into this system that I showed with those post-it notes and the percent errors that exist for each planet. So taking those error percentages and multiplying them out for the amount of time elapsed, I think that if I reposition the planets by that degree of error over that amount of time, it'll actually match my arm a bit better. So that's what I'm going to do now. Okay, so that's been done, and it matches what I expect. I did my research. This took 8 years to figure out. When I was born, all of the planets, not really counting the dwarf planets, but the major ones, although that happens to be the case too, almost all of them were on the same side of the sun, Venus being an exception. And if you look at my arm, Mercury, Earth, Mars, Jupiter, Saturn, and then Uranus and Neptune, there's very little on this side except for Venus itself. And if you look at the outer planets, Jupiter, Saturn, Uranus, and Neptune, there's this lovely arc going around as you go out in the solar system. And it was this alignment that allowed Voyager to do its grand tour. Voyager 1 passed by both Jupiter and Saturn, and Voyager 2 went by Jupiter, Saturn, Uranus, and Neptune. And the Voyager spacecraft were launched in 1977, the year I was born. So, as the planets continued to turn, and we had gravity assists, Voyager 2 made it all the way past Neptune and is now headed out of the solar system. I'm very pleased at this. The errors were quite large in certain cases, especially for the dwarf planets. It was only about 25 degrees for Uranus, about 12 degrees for Saturn. And what was it? 5 degrees for Neptune. Those are the errors that are built into this model. So regardless of where I set it, whenever I turn it on, over time it's just going to evolve into an inaccurate representation of the solar system. But it's still pretty. And I'm going to leave it calibrated at my birthday, and I'm going to run it forward from here. Nice thing is, because the dwarf planets and the outer planets with these long arms are on the same side of the Orrery, it doesn't take up quite as much space as if they were on opposite sides, although that will of course change because this thing runs a lot faster than real time. Anyway, that's it. I've finished it. Now I've got to find a beautiful place to put it and let it go. So I hope you've enjoyed this little instructional video and my messing around with my new toy. Ooh, that's fun. Oh, it's a musical instrument too. So enjoy, ask questions, and if you want to get one of these for yourself, it's from Eaglemoss Collections, and it's just so pretty, and I'm so happy to finally have one. Take care, everyone.